Good morning, class. Today we'll be discussing the Krebs cycle. What? The Krebs cycle. I mentioned it after my last lecture on glycolysis, didn't I? No. No? Oh. Well, you'll be learning about it today. No worries. The Krebs cycle, also known as the citric acid cycle, is the third metabolic pathway that occurs during cellular respiration. It takes acetyl coenzyme A and through a series of 9 chemical reactions creates carbon dioxide, NADH, quinone, QH2, and GTP. A number of these molecules are used by cells for, yes, you, energy. Correct. Energy that is necessary for cells to perform various functions. Let's look at the chemical reactions of the cycle a little more closely. There are a number of steps in the Krebs cycle, and it all starts with acetyl coenzyme A, which can be formed by converting pyruvate, a product of glycolysis, using coenzyme A, or by oxidizing fatty acids. In the first step, the enzyme citrate synthase takes acetyl coenzyme A and the compound oxaloacetate to form citrate. Citrate is then dehydrated into cis-aconitate, which is then hydrated into isocitrate. Carbon dioxide is subsequently removed from the intermediate compounds that follow, reducing the total number of carbons as the cycle proceeds. From the 6 carbons of citrate to the 5 carbons of alpha-ketoglutarate to the 4 carbons of fumarate and malate. As the bonds holding these carbons to the intermediates are broken, the electrons are moved to NADH and quinone, and one high-energy phosphate bond is directly formed in GTP. The Krebs cycle takes place in the mitochondria of cells, which makes sense considering how many of its intermediate compounds serve as intersection points for several pathways that occur in mitochondria. An example of such a pathway would be, yes, you there, the breakdown of amino acids? That's right. It appears that will be all for today. Make sure to thank Sir Hans Adolf Krebs for discovering this lovely piece of information you've learned today. Yeah. Sure?